Hello everyone. Can anyone please confirm if I'm audible? Okay. So I welcome you to week 7 of NPTEL Digital Electronic Circuits live session. We will be doing some questions today that may help you in your assignments and also in the exam. Okay. So let us begin. So let us start with first question. So I hope you all have gone through the video lectures already at NPTEL. So I'm assuming that you have seen those, so there might be some terms that I may use, which would be there in the video lectures. So if you are not familiar with them, please let me know, or I'll repeat them, else you can refer to the video lectures also. So the first question is implement D and T flip-flop using JK flip-flop. Okay. So the task here is to let us take it one by one. Let us first take D flip-flop. D flip-flop using JK flip-flop. So for this, what we need is we need truth table of not truth, let's say characteristic table of D flip flop, and we need excitation table of JK flip flop. So let us first write the D flip flop. So what do we have in D flip flop? We have D Qn plus 1. So 0 0 0 1 1 0 1 1. So what happens is D in D is when whatever is the state D, we know, right, Qn plus 1 equals to D. So I'll just write here 0 0 1 1. I'll just copy whatever D is at Qn plus 1. And now we have to write the excitation table for JK flip flop. So I'll write here JK. So I'll copy something. So I've already have these copied here. So let me take a screenshot here. This is the excitation table of JK. Right. So now let us see. When we have D, when we have Q 0 0 case, right? Here 0 0 case. So 0 0 we have J 0 and K is don't care. So J 0, K is don't care. This 1 0 case. In 1 0 we have don't care and 1. Don't care and 1. In 0 1 we have 1 0. And last is 1 1. So for 1 1 we have don't care and 0. Okay, so now we have made a we also made the excitation table for JK. Now what we do is, so let me write it in steps as a step 1. step 2. Now step 3 is write J and K in terms of D and Qn. Okay. So for that, the easiest way we know is K map. Let us make a K map. So J is when D is 0, Qn is 1, D is 0, Qn is 1, J is cross. So here we'll have a cross. And when D is 1, Qn is 0, we have 1. D is 1, Qn is 0, we have 1. Here also we have a cross. At 1, 1, we have cross. Okay. So this is for J. So with this, I'll, okay. So let us make a pair here. So this is a pair that we can make. And this will give us what? J equals to D. Now we'll make another K map for K. Now this is for K, right? K equals to something. So 1, 0, 1. When Q D is 0, Qn is 0, K is cross. So 0, 0 will have cross. When D is 0, Qn is 1, we have 1. So 0, 1, we have 1. Okay, we have just this. Okay, or do we have another cross? We have cross here. Okay. Now, when D is 1, Qn is 0, we have cross. D is 1, Qn is 0, we have cross. So again, we can make a pair here. So K is what? D bar, right? So effectively what we have got is J equals to D and K equals to D bar. So we want to make a D flip-flop from JK. JK, Q, Q bar. So we take an input D and apply its complement to K. So this is D flip-flop. Okay. Is there any doubt in this? If you have any doubts anywhere, please let me know. You can use your mic also, or you can type in. Okay. So let's do the next one also. Next one is T flip-flop using JK flip-flop. So if you're following, please, you may please write in chat also um, what are the equations you are getting for J and K for T flip-flop. They're fairly easy. Okay. So I'll repeat the steps. T Qn Qn plus 1 J K 0 0. So 0 1 1 Never to see toggle. One, zero. And that same JK I'll copy here. Then 0, 0, we have 0 cross 1, 1, we have cross 0, 0, we have 1, 0, 1, 0, we have cross 1. Okay, cross. Okay, so I made it. Okay, so again, now what we have to do is we have to make the K map. So we have to make two K maps actually. Yeah. One for J and one for K. Right. Okay. So then it is cross and 0, 1. So 0, 1 is cross. I'll put cross. 1, 0 is 1. And 1, 1 is cross. Here 0, 0 is cross. 0, 1 is 0. 1, 0 is cross. 1, 1 is 1. For both we will get this. For both the flip inputs, j equals to t and k is also equals to t. What that means is this is a t flip flop. Very easy. So our answer will be B. Right. B is the correct. Is there any doubt in any of the steps? So what we have to do is just for that flip flop that you want to make the characteristic table. The flip flop that you already have, make the excitation table. Then write the inputs in terms of uh, D and Q or whatever flip flop you require, and you will have your answer. So I hope it is clear. Since I do not see any questions, I'll move on to the next question. If you have any doubts, please feel free to ask. Okay. So the question is how to implement a clocked SR latch using only NOR gates. So we already so it is just a simple conversion of we have to just make this whole circuit using NOR gates only. For this, first let us write what is the Uh, let us write what is Q and Q bar in terms of R, C, and S. So here we can see, right, Q is, so for Q we have here Q bar and we have C dot R. Q is NOR of CR plus Q bar whole bar, right? This is Q. And Q bar similarly is Q bar, here we have Q, we have SC, SC plus Q whole bar. This is Q. So we have Q equals to RC plus Q bar whole bar. Now we have to convert it into a form with which we can make NOR gates, right? So we have RC, right? R can write it as RC can be written as RC bar bar, or if I use De Morgan's here, R bar plus C bar whole bar, right? So this is a form of, this is a NAND implementation, right? Output is barred with some inputs. Sorry, NOR implementation, my bad. NOR implementation is this, right? So I write it as like this: R bar plus C bar whole bar plus Q bar and again whole bar. So this is the NAND implementation. Sorry, I'm saying NAND again and again. It's a NOR implementation. Right. Similarly, we'll write for Q bar. Q bar we had SC plus R, right? C plus R. So we will do the same thing for this. SC we can write as S plus C whole bar. So it is S bar plus C bar whole bar. As R, instead of R, we'll write what? It's not SC, SC plus Q, sorry. Yeah, so write it like this. SC plus Q whole bar. Right. For this SC, we have SC plus C whole bar and just expanded SC like this, and Q is as it is. Okay. Now let us make a circuit for it. We have inputs R bar, C bar, and S bar. Right. We have R bar, C bar, S bar as inputs. So for that, what we need to do, NOT gate is just single input NOR gate. Okay. Next we have R and C are ended. Sorry, not ended. R and C are NORed here in this term, and in this term S and C are NORed. So, okay. Next we have simple latch operation. Right. So here we have R bar, C bar, S bar. We have R bar plus C bar whole bar. We have S bar plus C bar whole bar. Here we have Q. Here we have Q bar. These are the outputs. So they have written Q and plus Q. Okay. So the answer to this is Qn plus 1 is R bar plus C bar whole bar plus Qn. And this one, I think. B is correct. Is this clear? Okay, please let me know if you have any questions. I'll repeat it if you want also. Okay. So uh, let us move on to the next question since I don't see any questions. Okay. A truth table for X5 flip-flop is shown below. Design the flip-flop using JK flip-flop. Okay, good question. So again for design, so we have to make XY flip-flop. XY is just some random thing that we do not know, right? Using JK flip-flop. So what we talked about, right? First we need characteristic table for XY flip-flop. Second we need excitation table for JK flip-flop. Okay. Let us first make characteristic table for XY. Characteristic table what we have XY Qn Qn plus 1. So 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 0 1 1 1. So what do we have? When X and I are 0 and 0, we have Qn plus 1 is Qn bar. So it will be Qn bar is 1. If it is 0, it will be 1. 0 0, it will again flip to 0. For 0 1, we have 1. 0 1, we have 1. For in 0 1, we have 1 irrespective of the previous input. For 1 0, we have 0. 1 0, we have 0. 1 0, we have 0. For 1 1, we have again Qn bar. So if it is 0, it will be 1. If it is 1, it will be 0. Okay. So let us make it here also. Sorry. Yeah. X V. Yeah, 101001010101010. Okay. Now we have to make the characteristic excitation table for JK. I have it copied. For 01, we have, okay, it's wrong again. Yeah, for 01, we have one cross. One cross. We have other 01. This is also a 01 case. We have one cross. For 10, we have cross 1. 10, we have cross 1. So next we have again 01. So again 01 is one cross. Cross 11 is 1 cross 0. Cross 0 and 00 is 0. 0 cross and 10 is at the end also. 10, 10 is cross 1 cross. Okay. Now what we can do is we can make a truth table again. Sorry, not truth table. We can make uh, K map. X, K, X, okay. 0001. Copy of it for K also. So this is for J. This is for K. 000. We have 1. 001. We have cross. 010. We have 1. 011. We have cross. 100 is not there. 101 is cross. 101 is cross. 110 is 1. 111 is cross. So here we have, do we have here? This is a quad and this is a quad, right? So we can write it as x bar plus y, right? This is y. This yellow one is x bar. Okay. Now let us fill for k. For k, 000 is cross, 001 is 1. cross cross 1 1. Yes. So this one is x, this one is y bar. This x plus y bar. So we know now j equals to x bar plus y, k equals to x plus y bar. Okay. So if we want to make, we can make this so j k q q bars, x and y are the inputs. So this is the x xy flip-flop. Okay. So answer that we have is j is x bar plus y, k is x plus y bar. Okay, so what we did here is we made the characteristic table for xy flip-flop. Characteristic table, how we made is using this truth table. Then we wrote the excitation table for jk flip-flop. Excitation table for jk flip-flop. Then we wrote j and k in terms of x, y, and qn through these k maps. Okay, that's it. There's nobody in the meeting. Okay. Second, we'll continue to the next question. Okay. So the next question is find the values of P, Q, R, and S in the state diagram for the given sequence of logic. Okay. So here, first let us write what are the outputs in terms of input. So if this is Qn, this is Qn bar. So Qn is, okay, let's forget Qn, Qn bar for now. So just Q bar. So J is X XOR with Q bar, and K is also X XOR with Q bar, and Y is Q, so X XOR Q bar. So you can write it Qn. Okay. So okay. So let us make the table for this. X Qn Qn bar J K So need qn plus 1 and y. These two will fill later. First let us fill these. 0 0 0 1 1 0 1 1. So qn bar will be opposite of this. 1 0 1 0. J is x XOR q1 or k, and k is also equal to same. Y we also know x not q1 bar. We can fill jk and y. J is x XOR q1 bar. 1 is 1, 0 0 is 0, 0 1 0 is 1, 1 0 is 0, 1. It is x naught, so it will be opposite of this 0 1 1 0 1 0. Okay, so next status. So now we can use again the characteristic table of JK to get this right. So let me copy the characteristic table of JK flip-flop. I have it here. Equals to 0, j equals to 1, k equals to 1, j1, k1, q1 is 0. So this case we have, so we have q1 plus 1 is 1. We have 0 0 1, j0, k0, q1 is 1. We have 1, 1. J0, K0, Q1 is 0. We have this case also 0. J is 1, K is 1, Q1 is 0. K is 1, K is 1, Q1 is 0. We have 0. Correct. Okay. Now let us see the given state diagram also. 0, 1. So here we always write x upon y. It is output by input. Sorry, input and input to output. Okay. So for this 0 to 1 transition, we see 0 to 1 transition, right? We see x is 0, y is 0. So we'll write 0 0 here. 0 by 0. Then we have 1 to 0 transition. 1 to, this is 1 to 0, right? qn, qn plus the next one, next state. 1 to 0, we have 1 and 0. So we'll write 1 and 0. 1 to 1. 1 to 1. We have x is 0, y is 1. 0, 1. And 0 to 0. 0 to 0. 1 1. We have 1 1. So this was what? P Q R S. So we have P is 1 1, Q is 0 0, R is 0 1, and S is 1 0. D is the correct answer. Okay. So let us move on to the next question. For a master slave JK flip flop, which statements are correct? So the toggle frequency is the maximum clock frequency at which the flip flop will toggle reliably. So this is correct. The data input must precede the clock. Also correct. The input must generate fixed for a given time after clock triggering as transition. That's fine. This is also correct. Answer is A. The next question will okay. The given sequential circuit is designed using JK flip-flops is initialized with this and the state sequence for the circuit for the next clock cycle. Okay, so let us solve this. For this, let us first write the truth table of JK flip-flop. JK Q1 plus 1, 0, 0, 1, 0, 0, 1, 1. 0, 0 means hold, 1, 0 means set, 0, 1 means reset, 1, 1 is toggle. This is the truth table of JK. Now let us make the table required. We'll have present state, inputs, next state, Q2, Q1, Q1, Q0, J2, K2, J1, K1, J2, Q2, J1, K1, J0, K0, next state, Q2 plus, Q1 plus, Q0 plus. Okay, so it is given what? Initially it is 100. Okay, so that is right 100. Okay. And if you know the characteristic equation, you don't need to know actually. Okay, so we can write here J2 K2, J1 K1, J0 K0. So from here we can see J2 is Q1 bar, K2 is what? Q0, J1 is Q2, K1 is Q2 bar, and J0 is Q1, K0 is Q0 bar. Okay, let us use this. So J2 is Q1 bar. So Q1 is this, Q1 bar will be 1. K2 is Q0, Q0 is 0. J1 is Q2, Q2 is 1. K1 is Q2 bar, Q2 bar is 0. J0 is Q1, Q1 is 0. K0 is Q0 bar, Q0 is 0, so Q0 bar is 1. Okay, so in 1-0 condition, what will be the output? Q2. So 1-0 condition we have 1, so it will be 1. 1. In 1 0 again, it will be 1 1. Here we have 0 1. So 0 1 we will have here is 0. Okay. 0 1 is 0. So it will be 0. Now this will be our next state. So I'll write it here 1 1 0. Again, let us fill this. J2 is Q1 bar, Q1 is 1, so 0. K2 is Q0, Q0 is 0, 0. J1 is Q2, Q2 is 1, Q2 bar is 0. J0 is Q1, that is 1. Q0 bar is 1. Okay, so we have 0, 0. So 0, 0 we have hold. So hold is 1. 1, 0 we'll have 1 set condition. And we have 1, 1 that is toggle condition. So the 0 will become 1. 1. So now we have 1, 1, 1. Again, let us fill this. J2 is Q1 bar, that is 0. K2 is Q0, that is 1. Q2 is 1. Q1, Q2 bar is 0. It is 1, it is 0. 0, 1 is 0. 0. 1, 0 is 1. Again, 1, 0 is 1. So this is after third cycle. 0, 1, 1. So this cycle 1, 2, and 3. So from 1, 0, 0 we went to 1, 1, 0, 1, 1, 1, and 0, 1, 1. So we have 1, 1, 0. B is the answer. Do you have any doubts in this? I see some people have joined. So if you guys have any doubts, please let me know. Okay.
Can you please repeat that?
Oh, sure. So here we have been given this circuit, and they are asking what will be the initial state, and they are asking what will be the Q2, Q1, Q0 after 3 clock cycles. So for that, first what we do is we know these connections. We have these three flip-flops. We find J2, K2, J1, K1, and J0, K0. So J2, we see J2 is connected to Q1 bar. So J2 is Q1 bar. K2 is Q0. So K2 is Q0. J1 is Q2. J1 is Q2. K1 is Q2 bar. K1 is Q2 bar. J0 is Q1. J0 is Q1. And K0 is Q0 bar. K0 is Q0 bar. So till here it's fine, right? Next, we know the initial state, right? We know Q2, Q1, Q0 initially was 100 as given in the question. 100. So we'll write that here. Next, we find determine these inputs, right? J2, K2, J1, K1, J0, K0. We already know the equations for these in terms of these. So I'll just tell one this one. Let's say J2. So J2 is Q1 bar. Q1 is 0, so J2 will be 1. K2 is Q0. Q0 is 0, so K2 will be 0. J1 is Q2, so Q2 is 1. J1 will be 1. K1 is Q2 bar. Q2 is 0, so Q2 bar will be 0. J0 is Q1, so Q1 is 0. J0 is 0. K0 is Q0 bar. Q0 is 0, so Q0 bar will be 1. That is K0. Okay. Now, given these inputs, so now we see these inputs and look at the truth table. What will be the output, right? So for flip-flop 2, flip-flop 2. So when 1 and 0 is the input condition, so for 1 and 0 input condition, we get output as 1. So for 1 and 0 input, we get output as 1. Again, 1 and 0, we get output 1. For 0 and for 0 and 1, we get output as 0. So 0 1 output will be 0. Now this 110 that we have is now the present state in the next cycle, right? So it is 110. We again fill these and see again 00. 00 means the previous input. So previous input was 1, it remains 1. 10 means set condition. 10 we have 1, so 1. 10 is 1. 11 means toggle. So it was 11, so it will toggle from 0 to 1. Now this is the input condition. 1101. It has come from here. Now for this we again find these with these equations. Then again 01, 01 is 0. So it's 1. And this is our final. 011 is the final. So this was what we were asked. Find the next three states of the outputs. So we are 10. So initially we had 100. Now we had 110, 111, and 011.
Okay, sir.
Clear? Okay. So now the question is, what will be the output signal frequency if 4 T flip-flops are connected in cascade? Given the input frequency of T flip-flop is 400 Hz. So first we need to know what is T flip-flop for this. So, so T flip-flop for T flip-flop we have T. And copy. So I'll share these notes. I have written all the truth table, characteristic table, and excitation table for all the three. So in T flip-flop, we have when it is 0, it holds the previous state. Whenever it is 1, it toggles Q1 bar, right? So T Q1, Q first one will be Q1 bar. Okay. T is called toggle. T stands for toggle. Whenever T is 1, output will flip. It will be the complement of the previous output. Okay, so now we know what is a T flip-flop. Now let us see connected in cascade. So I'll draw what they're trying to say. So I'll cascade this outputs. So this is connected to Q bar, it's connected to Q bar, connected to, and this is the clock. This is the clock. So this is the cascade configuration. So they are saying that the input clock is of 400 hertz, right? So let us try to draw something. So let me draw the input clock. Let's say it is logic trigger. Let us say it is positive as triggered. So this is clock 400 hertz. So okay, now what will be the Q output, right? So Q, since T is Q bar, okay. Let us say suppose initially it was 0. It would be 1. So if it would be 1, it would flip to 0. It's now at Q2, Q1, Q1, Q0, Q2. Let us suppose initially it was 0, right? So Q2 bar will be 1. Q2 bar equals to T. So we know whenever there is T at this clock edge, the input to the flip-flop is T is 1. So this Q2 will flip. So let us flip this. If it is flip, it will go to 0. Right? Now here, now T equals to 0. So in T equals to 0 case, we know the output remains the same. It won't flip. So here at this clock edge, it sees that T is 0. So it will continue as it is. So here it will continue, right? Okay, I'm doing some mistake, I think. Okay. I think I'm missing something here. So anyways, I'll tell you the concept. I'm unable to draw the timing diagram as of now. So here what happens is at each stage, uh, at each stage frequency is divided by 2. So if it was 400, it will be 200 hertz here. It will be 100 hertz here. It will be 50 hertz here. So frequency divided by 2 to the power to the 4 different flops. There will be one more here. Yeah. So it will be 50 hertz here, and there will be one more where it will be 25 hertz. Okay. So 25 hertz will be the answer, but yeah, I'll try to see what is the timing diagram. I think I'm missing something here. So maybe this is not the
Sir, what is
candidate.
the answer?
Sorry,
Answer is
answer is 25.
okay, sir.
So at each output, the frequency will be f by 2. If it was 400, it will be 200 here. At next stage, it will be 100, next 50, and next 25.
Okay, sir. Okay, sir.
So if it's asked at the end of, I think four flip-flops are connected, right? So at the end of 4 output, input frequency divided by 2 to the power number of flip-flops. So 400 divided by 2 to the power 4, that is 400, 16, 25. Okay. So is there anything else that you want to ask in this question? Else we will move on to the next one.
No, sir. Move on to next question.
Okay. Yeah, yes, Pawan, you have written right. Okay, the following synchronous sequential circuit is designed with a JK flip-flop and a T flip-flop with J equals to A plus B bar, K equal to A bar plus B, and TB equals to A. Okay. If the initial state AB is 0, 0, find the sequence of states. Okay. Just give me a moment. Okay. Sorry for the interruption. Yeah. Okay. Okay. So we have a JK flip flop and T flip flop. These are given. Okay. So okay. So we know the characteristic equation of JK. So Qn plus 1 equals to JQn bar plus K bar Qn, and for T flip flop we have Qn plus 1. So T XOR with Qn. Right. So here Qn plus 1, here Q is A, right? Q is A, here Q is B. So an plus 1 equals to j an bar plus k bar an, and bn plus 1 p XOR with bn. Okay, so now let's see present state, next state. An bn an plus 1 bn plus 1. Initially it is given as 0 0. So 0 0. So an plus 1 will be okay. So for that we need j and k also. So we know j and k, right? J is a plus b bar, and k is a bar plus b. T is a, so it is a n XOR with b n. It is a n plus b n bar. The right here is going to be only for now. A plus b bar, a bar plus k bar is a bar plus b, right? So if I take it here, a bar plus a bar b bar plus a bar plus a b. So just hold on. Plus a dot b bar will be 0 a bar b bar plus a b bar b bar a plus a bar is b bar. So a n plus 1 is b bar, and bn is a n XOR with bn. So here, let me just reiterate what I have done. I'll take another page. So an plus 1 was given to us as J A N L skip A N J A bar plus K bar A, and also J was given to be A plus B bar, and K was given to be A bar plus B. So I put these values of J and K here. So A plus B bar, A bar plus K bar is A bar plus B bar A is A bar plus B bar A bar. 0 plus A bar B bar plus A B bar. So if I take B bar common, I have A bar plus A, it is B bar. That is how I've written this. This T was simply equal to A, so it will be A XOR with Pn. Okay, so let us fill this table now. N plus 1 is Bn bar, so B was 0, it will go to 1. Bn plus 1 is XOR this is 0. So this is next state will be copied here, 1 0. N plus 1 is Bn bar, that is 1, that is XOR 1. So 1 1 is there now. So it is Bn bar is 0, and XOR of these two is 0. 0 is the question. The Sierra state is surface. So 0 0 is the next state. So when it is 0 0, again an plus 1 is Bn bar. So Bn bar is what? 1, and Bn plus 1 is XOR of these two is 0. Okay. So the sequence of states is, so it is repeating, right? Again the same will follow 1 0 1 1. So states that are following are 0 0 1 0 1 1, then again 0 0. So this should be the answer: 0 0 1 0 1 1 0 0. B. Is this clear?
Okay, sir.
Uh, Sorry, my internet got lost. Uh, okay, so I hope this was clear. Let me see the chat. Okay, if not, please let me know. I'll the question first. Then, so why are we writing characteristic equation? Because we want to predict the next output, right? So to know that, we need to know the previous output, input and output. That then only we can predict the next output. So since we needed an plus 1, bn plus 1, we needed these equations. We wrote these. Then we put the j and k and t terms that are given already in the question. Determine what is an plus 1 and bn plus 1 in terms of an and bn. Then we just followed the sequence. And we found this sequence repeat 0, 0, 1, 0, 1, 1, and again. Okay, let us move on to the next question. Consider the following sequential circuit to determine the state sequences of Q0, Q1 for the next 4 clock cycles. The initial sequence is given as 1, 1. Okay. So it is very similar to the previous question, right? Yeah. Okay. So we'll do it as we did the previous question also. So let me type TA, QA, TB, TB. So both the inputs are always 1 to T flip flop, and okay, it's 0 and 1. So T0, Q0, T1, Q1. Okay, T1, T0, Q0, Q0, T1, Q1. For any clock, we need to find out the 4 clock cycles. So 2, 3, 4. So T0 and Q0 are always 1. And initially we know Q0, Q1 is 1, 1. So I'll write it as 1, 1. Okay, so we know the truth table for T flip flop, right? T, Q, N plus 1. 0, 1, whenever there is clock, it will remain Qn. Whenever it is 0, whenever it is 1, it will flip Qn bar. So here all are these conditions only. So in each cycle this will flip, right? So okay. So let us see. So when okay, this 1 1 was initially we had 1 1. So as soon as the first clock cycle arrives, it will see that t was 1. So it was earlier it was 1, it will go to 0, right? So this one will go to 0. Now the thing is this is this clock the clock here is not synchronous, right? So here it is this Q0 is being fed as clock to this, and these are all positive as triggered. So when Q0 when Q0 will go from 0 to 1, T1 flip flop will trigger. Whenever Q0 goes from 0 to 1, then only T1, then only this flip flop will trigger. But here it is 1 to 0, not 0 to 1 yet. So it will remain as it is. 1. In the next cycle, this will again flip. Now it is 0 to 1 transition, right? 0 to 1. So it will see it as a clock. And now it will see at this clock edge, its input is also 1, so this will flip to 0. This will flip to 0. This will keep on flipping 0, 1. Again, it will remain 0. Then it will see it is again going from 0 to 1 and its input is 1. Then it will flip from 0 to 1 to 1. Okay. So the next four states are, we had 1 1, then we had 0 1, 1 0, 0 0, then again 1 1. Yeah. 0 1 1 0 0 1 1. This, is this question clear to you? So
Yes,
here,
sir.
yeah. So only one thing is important, that you notice that this Q0 is being fed as clock. Both are not connected to the same clock. This Q0 will act as a clock, and since you do not see a bubble here, right? If it was bubble, that means it is a negative edge trigger. There's no bubble, that means it is positive edge trigger. So I'll write it. So whenever it goes from 0 to 1, whenever it sees this transition, it will trigger. That is the only thing that you need to take care of in this question. Okay. So, okay. Another question that I have is, okay, it is a theoretical question. The characteristic equation of a flip-flop is minimized representation of the next state by present input only. This is false. In characteristic equation, we consider both, right? T equals to, sorry, Qn plus 1 equals to T XOR with Qn. So we consider both the present input and present output or present state. So not input only. This is false. Don't care in excitation stages. Maybe it will take less than 1 second for flip-flop from one particular state to another. This is excitation table, not characteristic. So yeah, table. Okay, fine. So let's see. We have to tell which one are false. So let me give you one question, and then we can end for today. Just a moment. So take the question, convert D flip flop to T flip flop. A fairly easy question. Please try. So let me reiterate the steps. So how we were doing previously, right? Let us see. Go back. So those who had not joined earlier, I'll repeat how we are doing this conversion. Let us say we have to implement D. Sorry, we have to implement D and T using JK they have asked. So basically they are converting JK to D or JK to T. So what flip flop that we want is D flip flop, right? So the flip flop that we want, we write characteristic equation of that. The flip flop that we have, we write the excitation table of that, and then we find these in terms of this. So we'll do the same thing here. So basically, I'm saying 1 second. Implement D flip flop, D flip flop using D flip flop. So first step will be characteristic table of which flip flop, T or D. And excitation table of what? Please let me know if you understood how we do these conversions. Or if you have doubts, I'll repeat the previous questions once. Mm, do you guys understand what I'm saying?
So can you please repeat it?
So I'll repeat the first question. So this question is similar to the question before. So I'll repeat it since you guys had not joined. Tell you quickly how we did that. Okay. So question was implement D flip-flop using D and T flip-flop using JK. Right, so JK flip-flop is what we had. D flip-flop and T flip-flop was what we wanted. So first we took D, we wanted to build D flip-flop using JK. So how do we do that is we have a very you can say a very defined way to do this. So first the flip-flop that we want, we write the characteristic table for that. What is characteristic table? Input, Qn, and the next output. So this is the characteristic table. Then we write the excitation table of what we already have. So this is the excitation table, right? So this is the actually excitation table. So since this is just rearranged version of this, these both are same. So we write the excitation table of what we have. Then we write J in terms of D and Qn, and we write K in terms of D and Qn. Right. So to do that, we just make K map of D and Qn and write J what we found and K what we found. So let us do this example. It will be more clear. Okay, so we need characteristic table of what we want. We want T flip-flop and excitation table of what we already have. That is D flip-flop. Okay, so let me copy these two tables. I have them at the start of this presentation. We need characteristic table of this. Is the characteristic table. Sorry, this table. Characteristic table of this. This is characteristic table of T flip. We also need excitation table of D flip flop. In excitation table, what we have is Qn plus 1, Qn, Qn plus 1, and D 0, 0, 0, 1, 1, 0, 1, 1. I just remember it. Qn plus 1 is D is the answer 0, 0, 1, 0, 1. We will get. Okay, so let us write it properly. So if we have T, Qn, Qn plus 1, if we have 0, 0, 0, 1, 1, 0, 1, 1. We know when it is 0, 0, it will remain 0. When it will just hold its state 1. Whenever it is 1, it will toggle, toggle. Now D we know when D is Qn plus 1, 0, 1, 1, 0. Now we need to write D, D in terms of T and Qn. For that we can make a K-map if we need T Qn 0, 1, 0, 1. When it is 0, 0, D is 0, so we don't mention that. When it is 0, 1, it is 1, 0, 1, it is 1. I like it 1. And when it is 1, 0, it is also 1. 1, 0, it is 1. Okay, so we cannot form any pairs here. So we know D is equals to T Qn bar plus T bar Qn. The D equals to T XOR Qn. So to make T flip-flop from D flip-flop, we need a D flip-flop. Qn, Qn plus 1. We have some input coming T. We need an XOR gate. With it in coming from Q1. So this is T flip-flop made using D flip-flop. T flip-flop made using D flip-flop. So is this clear what we did here? Or do you want me to repeat it again? Is it clear?
So last step, please.
Okay. So what we did, again I'll reiterate completely. We wanted to make T using D. Write characteristic table of what we want, excitation table of what we have. So this is characteristic table of T, that is what we want. This is excitation of table of D, that is what we have. Then last step is this is the third step. Just write this in terms of these. So you see 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 0. This is simply XOR, right? You can see, right? It is XOR. So lastly, I just made the circuit. How you will make this is what you wanted, right? You wanted to make T flip flop using D flip flop. D flip flop that is already I have. I wanted to make a T flip flop from that. So I was getting QN.
Okay,
So I
sir,
made a
clear.
D flip flop. Yeah. Okay. Okay. Fine.
Okay. Sir, the same link in the same link.
Yeah. Yeah. Same. I'll share the
Okay.
link here if you want. Just a minute. So you can access the video link and also the PDF link in through this. I'll share. I'll upload it right after the class. Okay. Thank you all for joining.
Sir,
Yes.
Sir, actually, we were going on week 8, but
Okay,
we have lag behind 1 week because week 8 we have doubts because our assignment date is last date is tomorrow.
okay,
Okay, but we are discussing week 7. We are lag behind a week. So, sir, the doubts of week 8, if we ask it before tomorrow, then we have make more numbers. But
okay.
after
So,
that,
okay,
our
yeah,
assignment date is gone.
that is true. So actually, since we are directly solving the assignment, so that is why we are instructed to lag behind 1 week.
Okay,
So
sir.
if you have doubts, so we you can also email if there are some specific doubts. I'll try to clear them, but the tutorial of week 8 will be taken next week only.
Okay, sir. So in the email ID given, I have
Yes,
to
yes.
share if you have any specific. Okay, sir.
Yeah, if you have any doubt, you can share it there.
Okay, sir.
I'll
Okay, sir.
try to solve it. Also, whenever you are asking any doubt in email, please also include whatever solution that you have attempted, so I can see like if you are going in correct direction or not.
Okay, sir. Okay, sir. Thank you.
Okay, thank you. So I'll end the session now.
Sir, 1 minute. I have to copy the link.
Okay, sure.